In this lesson, we're going to begin studying adding and subtracting radicals. In this case, will be square roots. So this will be our first introduction into adding and subtracting square roots. And so we're going to, first of all, talk about like terms, what like terms are in terms of square roots. But first of all, let's kind of review something from a previous course. So from a previous course, we know that we can combine like terms such as 7x plus 2x. So if I wanted to add these two terms together, I could because those were like terms. If you recall, both these terms have the same variable x, and they're both being raised to the same power. So x to the first, x to the first, right? And so I could look at their coefficients and say, hey, I have 7 of these x's, and then I have 2 of these. So altogether, I have 9 x's. I could have also used the distributive property. So in other words, you see they have a GCF of x, right? So I could factor out an x, and I get x times 7 plus 2, and 7 plus 2 is 9. So I get x times 9, or 9x, okay? So these were like terms. I also know that these are like terms. Let's say 8x squared minus 3x squared. So I know those are like terms because these two terms both contain the variable x, and they're both being raised to the same power. So if I wanted to use the distributive property again, I could factor out an x squared because that's the GCF. GCF is x squared, and so I get x squared times 8 minus 3. So using the idea of the distributive property. And so 8 minus 3 is 5. So this becomes x squared times 5, which is equal to 5x squared. Okay? And so most students, though, remember, most students won't use the distributive property. They'll just look at these two terms and say, all right, those are like terms, the idea of like terms. So therefore, all I need to do is, in this case, subtract their coefficients. So 8 subtract 3 is 5, and so I get 5x squared. I can do the same thing with square roots. Remember, or radicals, cube roots, fourth roots, doesn't matter. But we are focusing on square roots in this lesson. So we can use the same idea with square roots. So for example, if I have 6 square root of 3 plus 4 square root of 3, are those like terms? In other words, can I write this as one radical, one term? The answer is yes. Because notice just like with the variable x, think of this as being your x, so to speak. So I would have 6 of these square root of 3's plus 4 of these square root of 3's. So how many square root of 3's do I have altogether? I have 6 plus 4, which is 10. So this would be 10 square root of 3's. And so I know that I would use the square root of 3 to determine my like terms, because if I look at this in terms of a GCF, what do these two terms have in common? They have a square root of 3 in common. So using the distributive property, I could factor out a square root of 3, and I get 6, because square root of 3 times 6 is 6 square root of 3, plus 4, because square root of 3 times 4 is 4 square root of 3. And notice what's 6 plus 4? Well, 6 plus 4 is 10, so this becomes 10 square root of 3. Okay, so in terms of these two terms, these are like terms because they both contain the square root of 3. Okay, so radicals such as these are like terms. The next two terms, like 7 square root of 5 and 2 square root of 5, those are also like terms. So these are like terms. Because why are those like terms? Because both terms contain the square root of 5. So then you may say, well, what makes radicals like terms? All right, so here's what makes radicals like terms. So like radicals, so radicals that are like radicals, have the same index and the same radicand. The same index and the same radicand. Okay? So if I go back over here, both these terms, if you look at the radical, what's the index here? Remember, there's no the square root, right? So there's nothing, there's no index listed, it's understood to be a 2. What's this index here? 2. So they have the same index. Do they have the same radicand? Yes. So that means I can combine those two into 1. Okay? Look at the square root of 5. Same index, same radicand. They're both 5s. So that means I can write this. If I were to add those, so for example, if I want to say 7 square root of 5, let's say subtract instead. 2 square root of 5, I can write it as one radical. What's 7 square root of 5 minus 2 square root of 5? Well, that's going to be 5 square root of 5. 7 subtract 2 is 5. And so I have 5 of those. Okay? So that's what like radicals are. All right? Now, here are examples of terms that are not like radicals. So these are not like radicals. So here's some examples. So here's one example of terms that are not like radicals. 7 square root of 3, comma, 2 square root of 5. So the reason those are not like radicals, they have the same index, 2 square root, but they don't have the same radicand. They don't have the same radicands. Don't have the same radicands. The radicands are different. All right, so you cannot combine those. You cannot write this as one radical, okay? And let's look at this one. So another example of two terms that are not like radicals would be something like 6 square root of 5 and 2 cube root of 5. You may say, well, they have the same radicands. That's true. They both have the same radicands, but they're not like terms. In other words, I can't combine those as one. And the reason is, look at the index. What's this index here? That's a 2. What's the index here? That's a 3. So they have different indices. So let me write it this way. The index of each is different. Okay? All right. So now let's look at some examples. So I think you have enough information there to where we can just look at examples now. So the directions will say, add or subtract as indicated. Okay, or it just may say add or subtract. All right, so here's number 1. Number 1, let's suppose we had 7 square root of 6 plus 2 square root of 6. What do you think the answer is? All right, so first of all, are those like terms? Are these like terms? Yes, because they both have the square root of 6. So now all you got to do is look at the coefficients. This is a 7, this is a 2. So how many do I have altogether? 9. So if I wanted to use the distributive property, I could factor out a square root of 6, right? And so I get 7 plus 2, and 7 plus 2 is 9. So this becomes 9 square root of 6, which is 9 square root of 6. Okay? But you don't have to do this. Most students can look at this and right away say that that's going to be 9 square root of 6, all right, without having to factor out the square root of 6. Number 2, you have the square root of 7 minus 4 square root of 7. So let me just remind you something. So I have the square root of 7, right here. So notice that this square root of 6, that number that I was multiplying it by was a 7. This square root of 6, that number I was multiplying it by was a 2. Here, I don't see a number right there. What that's understood to be? That's understood to be a 1. Okay. So what is 1 square root of 7 minus 4 square root of 7? So if you feel you need to factor out the square root of 7, then go ahead and do that. So look at what you have. I'm going to go ahead and rewrite this. So if I factor out a square root of 7 using distributive property, I will get square root of 7 times 1 is the square root of 7 minus 4, right? Square root of 7 times negative 4 is this. So what's 1 minus 4? A negative 3. So I get negative 3 square root of 7. So that's what this is. So 1 subtract negative 4, 1 subtract 4, is negative 3. So the answer is negative 3 square root of 7. Okay? Number 3, I have 3 square root of 10 plus 2 square root of 6. Can I combine those into 1? The answer is no. So I can't combine these. So notice for this one, I can't combine. They're not like terms. Not like terms. So if it says add or subtract, then what you would say is just write the problem again. So the answer will be 3 square root of 10 plus 2 square root of 6. That's because I can't do anything else with it. So that's the answer. All right. Number 4, I have 6 square root of 5 plus 2 square root of 5 minus 3 square root of 5 plus 4. So in this case, I have 4 terms. 1, 2, 3, 4. Okay, so are any of them like terms? Okay, yes. How many are like terms? There are 4 terms altogether. How many are like terms? Well, the first 3 in this case. This, and this, because they all contain the square root of 5. That doesn't contain the first square root of 5, right? All right, this term is not alike any of these terms. So since these are like terms, that means I can write all of these as one term. So what is 6 square root of 5 plus 2 square root of 5? Okay, that's 8 square root of 5, right? And then what is 8 square root of 5 minus 3 square root of 5? All right, so remember what we're doing. So let me go ahead and write these 3 out. So if you look at the like terms, those 3, if you like terms, I have 6 square root of 5 plus 2 square root of 5 minus 3 square root of 5, right? And so what is the first 2? 6 square root of 5 plus 2 square root of 5. Well, that's 8 square root of 5. And over here, just subtracting 3 square root of 5. And so what's 8 subtract 3? Well, it's 5. And so you get 5 square root of 5, right? So that's this right here. So I get 5 square root of 5 plus 4. And that's all you can do. You can't combine those, right? So leave it alone. That's it. Just like we said here, we couldn't do anything with this, so just write it over. So here, don't say it's 9. Don't say 5 plus 4 is 9. You can't do that, right? Because it would be 9 square root of 5 if you had a square root of 5 here. But those are not like terms, so you cannot combine them. Don't write it as 1. So that's your answer. Now, remember, addition is commutative. So if you want to change the order, you can. So if you want to write this as 4 plus 5 square root of 5, you can. It does not matter. All right, so that's number 4. Number 5, we have 6 square root of 11 plus 3 minus 13 square root of 11. All right, so I have 3 terms. 1, 2, 3. Are any of them like terms? Yes. The ones that contain the square root of 11, right? So I'm going to underline those. So I have this and this. So basically what I have is this. I have 6 square root of 11, and I'm subtracting 13 square root of 11. So if you need to use your calculator, use your calculator. 6 subtract 13, because remember you can factor out, and most people don't do this, but you can distribute, you can factor out the square root of 11 using the distributive property. And so you get, when you factor out the GCF, square root of 11, you get 6 subtract 13. And so when you calculate, if you don't know this right away, then just use your calculator. 6 subtract 13, and you get a negative 7. So you get negative 7 square root of 11. So these two, when I combine them, is negative 7 square root of 11, and then plus 3. That's all I can do. I cannot combine those because this does not contain a square root of 11. So that's it. Now, if you want to change the order, you can. So remember, addition is commutative. So another way I can write this is to say 3 minus 7 square root of 11. Okay? So same thing. 3 minus 7 square root of 11. Okay, number 6. Let's suppose we had this in number 6. You have 8 square root of 3 plus 3 square root of 3 plus 6 square root of 5. All right, so I have 3 terms. 1, 2, 3. Are any of them like terms? Okay, which ones? The first 2, because those are the ones that contain the square root of 3. This one's square root of 5. Okay, so remember, like terms must have the same indices, so the index must be the same, and the radicands must be the same. So these 2 radicands are the same, and both are square roots, so those are the only 2 like terms. So what is 8 square root of 3 plus another 3 square root of 3? So in your mind, you have this, 8 square root of 3 plus 3 square root of 3. So if you want to factor out the GCF, you can. That's the square root of 3 times 8 plus 3. If you factor out the square root of 3, and 8 plus 3 is 11. But you don't have to do this. You don't have to do this part. Most students don't. So they just look at, I have 8 of these, I have 3 of these. Altogether, I have 11 of those. And then plus 6 square root of 5. That's all you can do. Now, if you want to change, now you can't combine those, right? Why not? Why are those not like terms? Those are not like terms because the radicands are different. Now, if you want to change the order, you can. So you can say 6 square root of 5 plus 11 square root of 3. Okay, it does not matter. All right, and then number 7. So let's suppose number 7, I had this. The square root of 6 divided by 6 minus 5 square root of 6 divided by 4. Okay, so I put that in there because I just want to remind you about fractions, about finding the LCD and all that. So notice those are like terms because they both of these contain the square root of 6. I just got to find the LCD to write it as one radical. So if we look at this is a 6, this is a 4. So what's the LCD of 6 and 4? It's 12. So I'm going to write two fractions with that denominator, right? And so what is that? I got to multiply this 6 by the denominator to get 12, 2. So what I do to the denominator, I must do to the numerator, right? So the square root of 6 times 2 is 2 square root of 6. Okay? Now over here, what do I need to multiply this 4 by to get 12? Well, I need to multiply by 3. So if I multiply the denominator by 3, I've got to multiply the numerator by 3. All right, so I have 5 times the square root of 6 times 3. So what's 5 times 3? Remember, multiplication is commutative. You can multiply in any order. Now, you don't say the square root of 6 times 3 is the square root of 18. That's not true. Okay, so be careful. Don't say the square root of 6 times 3 is square root of 18. That's not a true statement. If this was the square root of 3, then that would be true. No, the square root of 6 times the square root of 3 is the square root of 18. But that's not what this is. That's just a 3. But remember, I can multiplication is commutative. I can multiply in any order. So I can multiply the 5 into 3, though. That's 15. So I get 15 square root of 6. And now notice that I can combine these as one fraction. So look at the numerators. I have 2 square root of 6 minus 15 square root of 6. So it's 2. So I can factor out a square root of 6, and I get 2 minus 15. So square root of 6 times 2 is 2 square root of 6. The square root of 6 times a negative 15 is negative 15 square root of 6. So what's 2 minus 15? Well, negative 13. So I got negative 13 square root of 6. So that's what this becomes. So this right here becomes negative 13 square root of 6 divided by 12. And that's your answer. Okay? All right, so that is the lesson on adding and subtracting, and we're dealing with square roots with like terms. And then the next lesson, we're going to look at adding, subtracting square roots that are not like terms. So you're going to see what's going to happen there.